In this tutorial, I'm going to be talking about the shading properties of glass. And the nice thing about glass is that it's actually very easy to come across the physically accurate reflectance value. And I guess this is because it's a substance that's been of great interest to physicists over the years, so the correct reflectance value is very well documented. Personally, I came across the reflectance value for glass when I was reading this book by Richard Feynman. I didn't actually understand most of the book because it was about quantum physics, but I did take away one thing from it, which was very useful, which is that glass reflects at 4% when looked at straight on. And this reflectance value of 4% is actually shared by most transparent materials, so it also applies to water and clear plastics, but also, for example, varnishes that might be applied to wood. So if you have a highly lacquered piece of wood, it is also going to be reflecting at 4% because the varnish coating has that reflectance value. So now that we know the actual correct reflectance value for glass, we can build a glass shader that is going to be pretty accurate. So in order to demonstrate this, I've put together this simple scene. I've gone to my meshes presets and I've loaded this abstract sculpture, but I've removed the glass material and replaced it with one of my own, which at the moment is just a base material. I've also gone to the assemblies and double clicked on the sweep. And then I've resized the sweep to fit my scene simply by clicking this red box and dragging these scale handles here. And other than that, there's simply the default GI and a directional light in the scene. So you can rebuild this scene very quickly and easily. It's pretty straightforward if you want to follow along with me as I talk you through the shading of this glass sculpture. So let's start shading this material. So I'm going to select the glass material in the scene, and we know that glass is mostly transparent with a small amount of reflection. So we can turn the diffuse amount to 0 because there's no diffuse component to glass at all. We don't need conserve energy because conserve energy in Modo basically only affects the diffuse. What it will do is when you get to the glancing angle and the reflection amount increases, it will automatically darken the diffuse. It will lower the diffuse amount. But since we're not using any diffuse here, conserve energy is not something that we're going to use. We are going to do some energy conservation, but we're going to have to do it manually, and I'll show you how to do that in a minute. Now, when it comes to the specular, we know that the value is 4%. The Fresnel is close to 100. You can put in 100 if you like. I tend to put in 99.5 because I'm assuming there's going to be a little bit of energy loss somewhere along the way. The roughness is very low because essentially glass doesn't have blurry reflections unless it's frosted, so regular glass has sharp reflections. So I would use a very low roughness value, something like 2, maybe even 0, definitely no more than 5. Now I'm definitely going to tick match specular because that means that I can manage my specular and reflection together in the specular properties, which makes a lot of sense really. There's no need to decouple them. I'm not going to use blurry reflections because, as I said a minute ago, regular glass has got sharp reflections, so we can break them up with a bump map, but we definitely don't want them to be blurry. So next I'm going to go to the transparency tab, and this is where we need to think about energy conservation and to balance our values out. And it's perfectly logical if you think about it. If 4% of the light is being reflected on the surface of the glass, that means that only 96%, the remaining 96%, can be transmitted through it. So when it comes to the transparent amount, you don't want to put 100%, you want to put 96% to account for the 4% that's being reflected. Now you can see as soon as I make the glass transparent, it disappears from the scene, and that's because the refractions are going straight through. Now, as you know, glass has got a refractive index, which essentially means that the light is slowing down as it goes through it. So we need to enter the correct value. Now, it's around 1.5. You can actually just cheat and use one of the presets that come with Modo. So I'm going to use this one, zinc crown glass high dispersion, which is set at 1.52. And you can see as soon as I do that, the object becomes visible again because we see these sort of dark refractions in the edges. These aren't actually entirely physically correct because we need to go and play with the ray tracing settings, which we'll do in a moment, but it's essentially the same principle. It's thanks to the refractions in the edges of the glass that the object becomes visible again. Which brings me to a pretty crucial point, which is to say that the environment that you choose is going to have a profound impact on the look of your glass. Since glass is transparent, essentially what you're seeing is the environment itself reflected and refracted through the glass. So I'm going to start just by making the sweep a little bit darker because the image is extremely bright at the moment. So let me just select the sweep controls and just make it a little grayer. And next I'm going to select my environment material. Now the problem I've got here is that this environment is pretty low contrast. At the moment it's a gradient. I can change it to a solid and sort of make it lighter and darker, but you see that obviously that's going to lighten and darken the scene, but the glass itself isn't really becoming any more interesting, and that's because the environment is low contrast, so all the reflections and refractions are also very low contrast. So if I want a little bit of contrast in the glass, I'm going to need to put some contrast into the environment. But before I do that, there's a property I need to go and change in the render item, and that is the refraction depth, because at the moment it's set to the default value of 8, and that's way too low, especially considering how complicated this object is with all the overlapping layers of glass. And the fact that the refraction depth is set so low is partly why I've got these very dark edges here, because once the rays are terminated, they turn to black by default. Now we can change that color in the glass material, and that's something I'll be doing later. But for now, let's go to the render item, and in settings you'll find reflection depth and refraction depth. I'll leave the reflection depth at 8. If you want to increase it for increased accuracy, then you can. But for now, I'm going to look at the refraction depth. Now, if we start with the maximum value, which is 64, you can see that when I enter that, it's going to profoundly change the look of the glass. Now, having set it at 64, what I'm now going to do is gradually reduce it until I get a visible loss of quality, because you don't really want to maximize a setting if you can avoid it. So let's go down to 32 and see how different that is. Well, it's pretty similar to 64. I can see there's a slight darkening on the edges, but it's not enough to bother me. So now I'm going to try 24. Well, that's starting to darken a little more, but I'm going to keep reducing just to see how much I can get away with. So now I'm going to go to 16. And 16 really is starting to visibly darken these edges. So for now, I'm going to return to 32 because that seems to be a pretty good compromise in terms of getting the right level of quality without having a setting set way too high. So this is half the maximum value, and it seems to work quite well in this particular case. So with the refraction depth now correctly set, I can go back to thinking about the environment that my glass is set in. So what I'm going to do is I'm going to go to the environment presets, and what I need to do is just to load a fairly high contrast environment. Just to demonstrate what I mean, if I load a really low contrast environment, for example this sort of overcast day, let me just double click on that, you can see just like before when I was using a gradient or a constant color, it just gives a really boring result because there's just not enough contrast in the environment to create pleasing reflections or refractions in my glass. So I need to look for a preset that has some contrast. So I'm going to go back to the indoor environments, and let's try something like this industrial environment, and you can see straight away this is much better. I've got some sharp reflections showing up, I've got some dark refractions showing in the edges of the glass, and this is the kind of thing that's going to show off my glass in a much more effective way. It's just going to make it more visible, because otherwise if you've got a piece of glass in a very low contrast environment, it's actually going to be quite hard to see. You need some strong contrast to be caught in the reflections and refractions just for the glass to be separated from the background. And in fact, I can demonstrate this point even more clearly if I create a new scene and then I go to my assemblies once again. There's actually a couple of glassware studios here that you can load and experiment with. So I'm going to load the high key one. Just double click that and let's wait a second for it to load into Modo. We change the camera to the glassware camera, and it's coming a little bit bright. I think some values are probably slightly too strong, so let me just reduce one of the spotlight so that we can see things a little more clearly. But you can see here the idea is that I've got these very dark reflectors on the edges of the glass, and it's these dark reflectors which are being caught here by the refractions, and this is essentially what is separating the glassware from the background. If I actually go to the item list and just hide the reflectors, you'll see once I do that, you see the glass is much harder to see because it doesn't have these very dark refractions. So that is what you need. Here I've got a very high key environment with some very dark reflectors which are providing the contrast that is needed to separate the glass out from the background and make it easier to see. And I can demonstrate exactly the same principle but in reverse if I create another new scene, and this time I load the low key glassware environment. And you can see that this time the glass is set in a dark environment, but I'm using some very bright lights on the edges of the glass once again to create some high contrast refractions, which will help to separate the glass out from the background. Without these high contrast refractions in the edges of the glass, this glass would be very hard to see. You'd still see these reflections here, but the edges would be practically invisible. So let me just close these two new scenes and return to the glass scene. And you can see the environment is very, very important. The environment is what creates the interest in your glass, and it's what helps to make the glass visible. So now that we've covered the basics, I'm going to return to the glass material and we're going to look at some of the more advanced options. So if I go to the Transparency tab, the first thing you're going to see is the Absorption Distance. Now, I'm sure you've noticed that in many cases, the edges of a sheet of glass have got these green edges, and that is because there is a slight amount of color within the transparency. So one way that you can recreate this effect in Modo is to give a color to your transparency and then to set an absorption distance. It's not actually the method that I usually use because in actual fact, using absorption distance in Modo does cause a couple of problems, which I'm going to demonstrate, but let's just go through the motions. If I set a sort of greenish blue transparent color, make it a little bit darker, something kind of like that. You can see my glass turns very green, but that's because I've got the absorption distance set to 0. So let's set it to something like 2 meters, and you can see that now the greenish color is only found on the edges and in the shadow. The actual main body of the glass looks much clearer than it did a second ago. But the amount of green that I'm now finding in the shadow is a problem for me. Considering we're dealing with a clear sheet of glass, I wouldn't expect to find so much colour in the shadow. If it was a coloured piece of glass, then sure, but with clear glass, I would expect the shadow to be pretty clear. Now, of course, at the moment, the shadow isn't particularly realistic because I'm not using caustics. But this is just to say that there's two problems that I found with using absorption distance in Modo, and this is one of them. I'll show you the other one a bit later on. So for now, I'm going to make the transparent color white again, and I'm going to reset the absorption distance to 0. So instead of using the absorption distance, what I'm going to do is I'm going to cheat. So I'm going to go to the render settings once again, and I'm going to reduce my refraction depth down to 16 so that we've got a bit more of the sort of dark edges coming back through simply the fact that the refraction rays are being terminated. Now, if I go back to the glass material and I go to material rays, here I can actually specify an exit color so that when the rays are terminated because they've hit the limit of refractions, I can specify what color they're going to be. So if I just make them a dark green color, you can see, I mean, this is a complete hack. You need to make it quite dark. But the illusion works pretty well, and I'm now getting these sort of greenish edges on my glass. And what's more, they're going to be really cheap to calculate because I'm actually cheating completely and terminating the rays early. So with that done, I'm going to return to the transparency settings, and the next thing I'm going to look at is dispersion. Now with dispersion, you really want to enter very low values. I'm going to start with 0.1, which I think is probably going to be too high, but you'll see as I enter this, I get a sort of rainbow effect in preview. But in fact, for dispersion, you really need to do an actual render because it doesn't always show up very clearly in preview. So what I'm going to do is I'm just going to pause the video and do a test render. So I've done a test render with dispersion on, and I'm going to zoom in so you can see the effect it has. If I compare it to a previous render without dispersion, you can see that with dispersion on, we really get a much more realistic effect. It just looks much more like glass because we've got a little bit of separation of the spectrum of light going on in the glass itself, whereas this just looks very dry in comparison. Obviously, the other thing to compare is the render time. With dispersion on, this scene is rendering in just under 2 minutes, whereas with dispersion off, it's rendering in 26 seconds. So it is fairly costly to calculate, but it just adds so much more realism to the glass that I really think it's worth doing. However, I also do think it's a bit too strong here, so what I'm going to do is, in fact, I'm going to enter a value of 0.05 and do another test render just so we can see how that compares. And here is the render with the latest settings. So you can see if I zoom in, it is much more subtle, the dispersion, than on the previous render. It's quite hard to see, but if I compare it with the render without dispersion, you can see it is still there, and it just adds that tiny little bit of realism without being overpowering like I found it here. So it's definitely a setting worth using. It does add to the render time, but I think it's one of the key things that makes glass look realistic. The next thing I want to talk about is the shadow. At the moment, I'm just using the default ray trace shadow, which is very unrealistic because there's no caustics. I've taken a couple of reference pictures just to show you what an actual shadow looks like when it's being cast by a transparent object. So in this case, I've pointed my camera down into the bottom of a glass and it's resting on a sheet of paper. So you can see the shadow which is being cast by the sun, and we've got this dark area. And within the darker area, we've got these very bright spots called caustics. And these are caused by a lensing effect. Essentially, we've got a curved, transparent surface which is transmitting light. But as the light is transmitted through, it's also being refracted. And the curvature means that the refraction is focusing some of the rays of light into these very bright spots. But while it's focusing a lot of the light into these bright spots, less light is going to be hitting these areas here, which is why they're so much darker. So while you might think that a transparent object doesn't necessarily cast dark shadows, well, that would be wrong, because the refraction causes some light to be bent away from these dark areas into these very bright spots here. And also, while we're looking at this picture, notice that the dispersion is also visible in the caustics. You can see there's this sort of rainbow prismatic effect clearly visible here in the shadow cast by the glass. And I've also got a second picture which demonstrates the caustics really beautifully. So obviously in this case the liquid is less transmissive than the glass. You can see it's visibly darker and it's got this bright red color. So the shadow cast by the liquid is going to be darker than the shadow which is cast by the pure glass. But even up here where the pure glass is, you can see that there's a lensing effect. There's a bright spot here and a dark spot here. So this is still a transparent object casting a pretty dark shadow right here. And obviously in the middle you can see that the sun's rays are focused in this very bright caustic. So I'm going to return to the Modo scene and we're going to look at the caustic settings. So there's a couple of things you need to know about caustics. Basically the caustics are only going to be projected within the volume of a light. So if you have a spotlight, you define where the caustics are going to be projected from within the cone of a light. And in a directional light, if I can go and locate the light here, you can see there's this square area and this is where the caustics are going to be projected. It's just that they're incredibly costly to calculate in terms of memory. This is why on the directional lights the area of projection is limited by this square. So if you're using directional lights, just make sure that your objects fall within this rectangle. It's defined here as the shadow photon size. It defaults to 2 meters. You can make it bigger or smaller if you need to. So to enable caustics for my direct light, I'm going to need to go to the render tab and to the global illumination settings. And if I go right to the bottom, I'll find these settings for the caustics. Indirect caustics are on by default for refraction anyway, but direct caustics for direct lights, like a directional light here, have to be enabled. So what I'm going to do is I'm just going to enable it and I'm going to leave everything at default and do a test render to see what things look like. And here is the resulting render. So if I compare it to the previous render, you can see it is indeed very different, and it seems to be much more realistic. We've got the dark shadowed area with the bright spots in the middle. And you can also see the dispersion is very visible with these sort of saturated colors within the caustics. However, if I compare it to the reference photo, it doesn't seem to be quite there yet, because in the reference photo we have got these very sharp spots here within the caustics, whereas here everything still seems to be very soft. And that's because we need to add more total photons. So if I return to the caustic settings, what I'm going to do is I'm going to simply multiply this by 100. I'm just going to add a couple of zeros on the end. Now, I'd advise you to be pretty careful when increasing the total photons value, because it can use a lot of memory. So on this machine, I've got 32 gig of RAM, so I'm quite comfortable increasing it to this very large number, but you do have to watch it. If you've got less RAM, if you've only got 8 or 12 gig, you won't be able to use quite as many total photons as I'm using here. And even for me, there's going to be an upper limit. I can add maybe one more zero and then maybe multiply it by 5, but after that I'm not going to have enough memory to go any higher than that. But having said all that, I'm going to do another test render and we'll see how it compares. And this is the latest render, so let me compare it to the previous render. You can see it is indeed very different. The dispersion is a little bit disturbing in the sort of blotchiness it's causing in the glass, and this is a problem that I've had with Modo for a long time. However, the sort of sharper caustics is just starting to appear. You can see there's this sort of boomerang shaped one here, and there's one here at the top. So I think the next thing to do is to add some more total photons. Now, as I said earlier, I've got to be pretty careful how many more I add, so I'm going to add one more zero and once again do a test render to see what that looks like. And here is the latest render. So I'm going to zoom in and compare it with the previous one. And you can see that every time I add more total photons, the caustics get sharper and sharper. And you can also see that as I'm adding more total photons, the sort of blotchiness in the middle seems to be getting a little bit better. But it's really nice to start seeing these very sharp photons appearing here. Now I'm going to try and add some more local photons this time as opposed to total photons, because what they're going to do is they're going to sort of soften the inside of the shadow for me. So I'm going to multiply this value by 4, so let's go to 128 and do another test render. And here is the render. So if I zoom in and compare it with the previous one, you can see that by adding more local photons, I'm really helping the quality of the caustics, because it's helping to smooth out the blotchiness that I was getting in the middle, while still preserving the interesting shapes that I was getting out here. So what I'm going to do is I'm going to do one final tweak to my caustic settings. I'm going to multiply my total photons by 5 to try and get that extra bit of detail, and I'm going to multiply my local photons by 4 to try and get a little bit of extra smoothness, and do another test render. And this is the latest render. And if I zoom in, you can see things are starting to look pretty good now. I've got some nice smooth caustics going on inside the glass. The blotchiness is pretty much gone, and I've still got quite a lot of these nice sharp shapes, and the dispersion is also visible without being overpowering. If I compare it to the previous render, you can see it's visibly better. My render time has also increased substantially. I'm now at just over 5 minutes, whereas before I was at just over 2 minutes. So you can see it is pretty costly, but the results are worth it. So with my dispersion and my caustics now working as I'd like them, I'm going to return to the absorption distance in my glass material just to show you the second drawback, because I mentioned earlier there's 2 drawbacks with it in Modo. The first one is the way that it affects the shadow, but I'm also going to show you another problem that I found with it, in that it also just doesn't work very well with dispersion enabled. So if I was to just add an absorption color, let's go for a sort of darkish blue-green, and add an absorption distance of 2 meters. And what I'm going to do, actually, I'm going to go back to my caustics, and I'm just going to reduce the total photons and the local photons a little bit, just so that the render time's a little bit faster. And I'm going to do another test render and show you what happens when you have absorption in conjunction with caustics and dispersion. And here is the resulting render. So you can see that if you try and use absorption at the same time as you're using dispersion, you get these very unpleasant results. And also the extra color saturation that it adds to the shadow seems to make the blotchiness of the caustics worse. So in a nutshell, that's why I tend to avoid using absorption distance in Modo. So I just set my transparent color to white unless I'm trying to render colored glass, and I set my absorption distance to 0 because that gives me much better results. So before moving on, I'm going to talk briefly about indirect caustics because you can achieve these in Modo as well. So to demonstrate them, I've turned off my directional light and I've added a softbox assembly from the standard content, and I've made the light very, very small and very, very bright. And that's because for caustics to be visible, you need a small and bright light, because otherwise they're just too diffused for them to be obviously visible. Now, Modo defaults to refraction only for indirect caustics, so we'll start by testing that. So I'm going to pause the video and do a test render. And here is the resulting render. Now obviously it's much harder with a softbox to get a visible caustic, simply because a softbox, even a very small one, is still a lot larger than a directional light. A directional light is basically an infinitely small point of light, so it's very easy for Modo to generate the caustics. But nonetheless, you can see that there is some caustics visible here underneath the glass. So I'm going to return to the scene, and this time I'm going to set the indirect caustics to be reflection and refraction by selecting both. And once again, I'll pause the video and do a test render. And here is the resulting render. Now if I compare it with the previous render, you can see that there is a visible brightening on the floor around the glass object, and this is because of the reflective caustics. When reflective caustics are disabled, the light that hits the glass and is then reflected onto the floor is simply not calculated by Modo. But when reflective caustics are on, this additional light does then appear in the render, so Modo will calculate what light is reflected off of the glass and then back onto the floor. But even with a small softbox, you're not going to get the very sharp, defined caustics that you get with direct lights. And that's simply because when you're using global illumination to provide your lighting, it's very difficult to make a small, bright light source without a very noisy image. One instance where I could imagine it happening is if you had an HDR with a very bright sun in it. In that case, you might have a small bright light source that could provide you some sharp indirect caustics, but in most cases the very sharp caustics are going to come from direct lighting. So before I finally wrap this up, I just want to talk about one final detail that you can add to your glass in order to make it more realistic. And that's simply to add a little bit of distortion in the reflections, because when you have large panes of glass, especially on things like buildings, you're often going to find that it's impossible for the manufacturers to make them perfectly smooth. So what you want to do in order to break up the reflections, just to add a little bit of distortion to the reflections, is simply add a procedural noise as a bump map. You'll see when I enable this one, see the reflection just slightly changes and we get a little bit of distortion. It's just much more realistic. So here what I've done is just added a simple type noise, not a fractal, simple type noise, and I've made the scale 1 meter. So it's just to add a little bit of waviness to the glass, and you'll find that adds quite a nice touch of realism to your renders of buildings and large scale sheets of glass. Now, of course, another attribute of glass that is rarely perfectly clean, you can add all sorts of maps to give the impression of dirt and grime and some changes in the roughness of it, say if there's fingerprints on it or if there's sort of dirty areas. But I think that would be a subject for a whole other video that I'll probably also cover one day. So for now, thank you for watching this video and I hope you found it useful.